In this problem, we're going to look at the common projectile problem and how to solve it. We are given the equation that this projectile is going to fly up and it's going to have this height. This equation will give us the height. We want to know, when is it going to hit the ground? How? Well, first thing to realize, since h is height, that means that when it hits the ground, h is 0. So we can take this equation and it simply becomes a factoring problem. First, we want to make it easy. Make the problems as simple for us as possible. So we want to factor out the greatest common denominator to keep the problem easy. Once we do that, it'll be much easier to factor. So I'm going to look at these problems. I'm going to guess that each of them, I can factor 16 out of each of them. And just so we have this minus sign gone, I'm going to factor out a minus 16. So we have minus 16. And we're going to test this. Let's see, t squared, that works. 64, we can do that minus, whoops, 4t. This one right here, I had to check my calculator. This was minus 60. Okay, so 16 times t squared, negative 16 times negative 4, 64. Negative 16 times negative 60, positive 960. Okay, so we want to find out where this equals 0, because h equals 0. So, well, 16 is never going to equal 0. We know that. So this has to equal 0. So now we have t minus 4t minus 60 equals 0. Okay, well, we know from factoring that this is going to be t minus something, t plus something. We know we have a minus and a plus because we have a minus right here. A minus and a plus multiplied gives you a minus. Two minuses? Nope, it'll give you a plus. We could have a plus and a minus, but that's just switching things around. How do we solve this? I don't know. What do we get? How many things can we multiply to get 60? Well, we could do 1 times 60. The difference of that would give us 59. But we need negative 4, so that's not going to work. 2 times 30. Difference of those would be 28. And that's not going to do the job. That's still too large. 3 times 15. Difference of those would be 12. Closer, but not what we need. How about 4 times, well, sorry, right, math error. That was 3 and 20, which would give us 17, 4 and 15, which would have given us 11. Still not small enough. Suppose we got 5. 5 times 12. That would give us, see the difference of those two is 7, we're closer here, 6 and 10. Difference of those, 4. Okay, so let's try that out. Move that away. I could have t minus 4, t plus 10. Sorry, crap, math error. Okay. T minus 6, t plus 10. Does this work? Let's find out. If we do FOIL, my first term is a t squared. Good. First outer, sorry, that'd be 10t inner minus 6t negative 60. This gives me positive 4t. I need negative 4t. Okay, so I did something wrong. This often involves a bit of trial and error. So let's try it a little bit different. I tried it with minus 6 and plus 10. I'm going to try it with plus 6 and minus 10. How does that change things? I still get a t squared, good. My outer terms give me minus 10. Maybe mark this with a different color so we can see the change. Minus 10. Now I get a positive 6t for my inner term. It's positive 6. My last terms gives me negative 60. Good. So now I get minus 4. Okay, so I have I can factor this as t, it's right here. So if I want t to get equals 0, that means t itself can be negative 6. I could have negative 6 right here. Then this equals 0. That would work. Or I could have a positive 10 right here. Don't put a plus right there, I'm just trying to point out that it's a positive number. Okay, because 10 minus 10 gives 0. That works. Of course, there would be a 10 right here as well. I just didn't write it in. Okay, so that means our possible answers for t are positive 10 and t equals minus 4. The best answer is going to be t equals 10. Let's see, this was done in terms of miles per hour, so I guess this would be 10 hours. That's one heck of a projectile, but oh well. Okay, and we probably wouldn't want to use negative 4 because that would be negative time, and in most cases that just doesn't make sense. Thank you.